Hello everybody, my name is Nikita Timra. I am from C department. Today we will be understanding transition isolation level in DBMS. So, what is transition isolation? Transition isolation is a property that determines how transition integrity is visible to other transitions. It plays a critical role in concurrency control and affects the performance of reliability of database operations. Understanding the concept is vital for effective database and management. So the importance of isolation level are important because they helps in balancing the performance of data consistency. By choosing the right level of database, administrators can minimize issues such as a dirty read, non-repeatable read, and a phantom read, ensuring that transitions are processed correctly. You can see here the app in the diagram. Here applications are there and their transition A and B is there, which is present in the database. Now we will be understanding read uncommitted level. So what is in the read uncommitted isolation level? It allows transition to read data that has been modified but not yet committed. This can lead to dirty read, where a transition read data that might be rolled back, potentially causing inconsistency in the result. You can see in the example there is a transition 1 and transition 2, where transition 1 is writing a data A and transition 2 is directly reading a data A without the transition A data is being committed. So that comes under the dirty read. So even if the data is written and it is uncommitted, so the data which has been written, that would be wasted in database. So next we'll be switch on the read committed level. So in read committed isolation level, transition can only read data that has been committed. This eliminates dirty read but allows for non-repeatable read, where data can change between read within the same transition. You can see in the example we have transition 1 and transition 2, where transition 1 is reading the data item A as 10 and transition 2 is writing the data item as 20. And again, when transition 1 is reading the data item A, so it finds the change which is 20. So this change is due to the intervention of T2, where it is writing and changing the data from 10 to 20. So this caused the repeated read problem, which won't be happen. Now we'll see the repeatable read level. So the repeatable read isolation level ensures that if a transition reads a record, it will see the same value if it reads it again. This level prevents non-repeatable reads but does not eliminate the phantom read, which can still occur. So we'll be understanding the phantom read through the example. We have a table where two rows are relevant for T1 transition and we'll be writing a query for particular condition C. So it finds two row as the relevant one. So it will be printing the particular row for the relevant T1 query. So after that, if we are performing the transition 2 for a particular same condition and different query, and it will be adding a new row in this. So after adding this new row, if we are executing again the T1 query, so the new updated row is being updated in this T1 also. So this new row which has been created, this is called the phantom row. So this whole process is known as the phantom read. Now we'll see serializable isolation level. It is the highest level of the isolation. It ensures complete isolation from other transitions, preventing dirty read, non-repeatable read, and phantom read, which we have seen before. However, it can significantly impact performance due to the increased locks. It is simple to understand. If the locks are increases, the impact of the performance in this are more in serializable level. So as we have seen the example of all the isolation levels and dirty read and non-repeatable read and phantom read. So simply we'll go through this table. You can see the dirty read is been allowed and repeatable read and phantom read are being allowed in read uncommitted level isolation, and for read committed level only the non-repeatable read and phantom read is been allowed, and for the repeatable read only the phantom read is been working executed in this, and for the serializable none of the reads are violated. Here we'll see choosing the right level. When selecting an isolation level, consider the specific needs of your application. Factors such as transition volume, data consistency requirements, and performance expectations should guide your decision to ensure an optimal balance. If we are making an application, it is simply telling us the right way and which level is being used for our particular application, so our application won't be violate any rules. And here is the conclusion of transition isolation level. Uh, in the conclusion, understanding transition isolation level is essential for effective database management. By careful selecting the appropriate level, organization can achieve a balance between data consistency and performance, ensuring robust and reliable database operations. Thank you for listening. Thank you everyone. Hope you have understand the transition isolation level. Thank you.